Hello everyone, welcome back to our channel. We were discussing about trigonometric functions, class 11th maths, ncert. Let's continue with the discussion. Now, in the last class, we discussed about the signs of trigonometric functions for different angles in different quadrants or different angles. And today, we'll discuss how they vary in different quadrants. But for that, first, a few basic concepts. We know that this line, the positive x-axis, can be considered as 0 because your initial side and your final side will be overlapped. As your angle increases from 0 to this point, that means as your final side shifts from x-axis to y-axis, you cover a total angle of pi by 2, positive pi by 2, since it's an anti-clockwise direction. As you progress, after covering the second quadrant, you'll reach pi. After covering third quadrant, you'll reach 3 pi by 2, then 2 pi ultimately. Your 2 pi line and 0 line will be the same. If you progress further, then again pi by 2 will be added to 2 pi, which will lead you to 5 pi by 2. This 5 pi by 2 will be same as pi by 2. They will have the same value. So if I write sine pi by 2, that value will be equal to sine 5 pi by 2. Next, what happens if you continue moving forward, you'll get 3 pi and then 7 pi by 2 and so on. But these are positive angles. What happens if you move in the counterclockwise direction? So from here, this point, now you're moving downwards. We know that if you're moving in a clockwise direction, your angle starts to take a negative form, or that's what we consider for our own simplicity or understanding of trigonometry. So when you move in the clockwise direction, the angle becomes negative. So from 0, as you move to the negative y-axis, you'll cover a total angle of minus pi by 2. As you move forward, covering your third quadrant to negative x-axis, you'll be covering a total distance from your initial value, which is this positive x-axis. The total value that you've covered is minus pi. If you continue moving forward, moving ahead in the clockwise direction, it is minus 3 pi by 2. Again, minus 2 pi. So you again started with 0 and you ended up with minus 2 pi. If you continue further, you'll reach minus 5 pi by 2, minus 3 pi, and ultimately minus 7 pi by 2. Later on, minus 4 pi. The earlier situation, you would have had 4 pi, positive 4 pi. So now we know that in a circle, these angles will continuously go on repeating themselves, and the values will overlap with each other. But what happens if I draw a straight line? If I have an x-axis with me and I'm plotting all these points, all these values, all these angles, angle values angles can take the value from minus infinity to plus infinity. So what if I plot all these angles from 0 to positive infinity and from 0 to negative infinity on the number line? Then how will the sine, cos, tan, cot, cosec, sec, how will these take shape? This is what we want to attain. Now, we also understood in the previous class that your sine value changes. Sine value is positive in the first and second quadrant. Now, based on this knowledge of the negative angles, we can easily say that your sine value is positive in the first and second quadrant, means when your x value or the angle is between 0 to pi. When x lies between 0 to pi. Your cos value is positive when your angle lies in the first quadrant and the fourth quadrant. Now, the fourth quadrant can be represented by minus pi by 2 and first quadrant by pi by 2. We're taking this notation because if we start over here and if we add on to the value of x, instead of starting from the positive x-axis, if we start from the negative y-axis, and if you keep on adding certain values, certain numbers to x, your x value increases, and ultimately you'll reach this particular point. So you can see that cos value is positive for when x value is between minus pi, and it keeps on increasing to plus pi, minus pi by 2 to plus pi by 2. Next, tan value. Your tan value is positive when it is in the first quadrant and third quadrant. So tan value is positive for first quadrant and third quadrant. In the first quadrant, your angles are between 0 to pi, 0 to pi by 2. So it's 0 to pi by 2 united with your x value. This is for x value from pi to 3 pi by 2. It's positive when this is the value of x. The same goes for cot. Cot is positive in the first and the third quadrant. So your x value will also lie between the same 0 to pi by 2 united with pi to 3 pi by 2. What about sec x? Your sec value is positive whenever your cos value is positive. So for sec value as well, your angle should lie between pi by 2 to minus pi by 2. Similarly, your cosec value is positive and your angle lies between 0 to pi, because cosec is sine inverse. Now you will use this information that you just attained along with how it is increasing. Like we know that sine value is increasing from 0 to pi, but how is it varying? We know that sine value is represented by b, the second value, the y coordinate of your these values, these coordinates which is mentioned. So this is your sin x value. For quadrantal angles means angles multiple of pi by 2, integral multiple of pi by 2. For quadrantal angles, your sine value will be equal to these circles. So let's start from 0, where you we'll consider the range first, where sine is positive. So sine value increases at x is equals to 0, sine is 0, and at x is equals to pi by 2, sine is 1. So a sine value increased in the first quadrant from 0 to 1. This is shown in this table. In the first quadrant, your sine value increased from 0 to 1. What happened further? Further, your sine value decreased to 0. Then your sine value again increased to minus 1, from 0 to minus 1. Then it decreased to 0. So first it increases from 0 to 1. Then it decreases from 1 to 0. Then it decreases from 0 to minus 1. Sorry, it decreases because minus 1 is smaller. I said increases by mistake. Then it increases from minus 1 to 0. What happens with cos? Your cos value is this first value. So this first value, it from 1 to 0, it is as x is increasing, it is decreasing from 1 to 0. Then it is further decreasing from 0 to minus 1. Then it increases from minus 1 to 0 and further increases from 0 to 1, and the process repeats itself. So your cos value first decreases from 1 to 0, then decreases from 0 to minus 1, increases from minus 1 to 0, and then further increases from 0 to 1. Let's plot sine and cos first. So we know that sine value is at x is equals to 0. So first quadrant, we know that your x value will be equal to 0 to pi by 2. This is from pi by 2 to pi. This is from pi to 3 pi by 2 and 3 pi by 2 to pi, nu into pi. So in the first quadrant is from 0 to pi by 2. Fine. First quadrant is from 0 to pi by 2, this particular region. What happens in this region? For sine value, it increases from 0 to 1. Now, y is equals to sine x. This is what we are considering. So, sine x value is depicted on y-axis. We know that sine x varies. In the last class, we studied that sine x ranges from -1 to 1. So, definitely there should be a point 1 and there should be a point -1 over here. Because your y on the y-axis, we will never get a value beyond 1 and beyond -1 according to our basic understanding. Also, sine value increases from 0 to 1, from 0 to pi by 2. Within 0 to pi by 2, first quadrant, sine value is increasing from 0 to 1. So somehow it is increasing. It takes this kind of shape. What happens at pi by 2? At pi by 2, it is decreasing from 1 to 0. This is your second quadrant, pi by 2 to pi. This decreases to this particular value. It further decreases from 0 to -1, decreases from 0 to -1, and in the fourth quadrant, it further increases from -1 to 0. This process repeats itself. So you'll again get this kind of wave kind of structure. This is called a wave structure. What happens over here? 0 to pi by -pi by 2. Now in the figure, we know that 0 to -pi by 2 is your fourth quadrant. So your fourth quadrant can be written as 0 to -pi by 2, -pi by 2 to -pi, -pi to 3 pi by 2, and this is 3 pi by 2 to -3 pi by 2, and 3 pi by 2 to -2 pi. So here, following these concepts, from 0 to -pi by 2, your sin x increases from -1 to 0, increases from -1 to 0. From this value to 0, then it decreases from 0 to -1. Prior to this, we'll get something like this. So it's a wave structure. Wave structure in such a case that sine 0 is 0, sine pi is 0, sine 2 pi is 0, sine 3 pi is 0, sine -pi is 0, sine -2 pi is 0. Everything in trigonometry that we studied in the last 3 classes are connected to each other. So it's very essential that you go through all of them to get a better picture of what trigonometric functions are like in practicality. So next, continue with this. This is for cos x. Now we've already studied that cos x decreases from 1 to 0 in the first quadrant. First quadrant, it decreases from 1 to 0. That means earlier it attained the value 1 at x is equals to 0, and then it decreased to 0. Later on, it further decreases from 0 to -1 in the second quadrant. So in the second quadrant, it decreases from 0 to -1. It takes the same shape. Yeah, there are two values, 1 and -1 over here, because y can never have any other value. It takes the same shape as sine with a shift in phase. Now, shift in phase, or here you can say shift in angle by 90 degree. So the whole sine wave gets shifted on the left hand side by 90 degree, or the whole cos wave shifts to right hand side by 90 degree. The shape of the wave remains same. We also know that -1 is less than equals to cos x is less than equals to 1. Let's see for tan and cot. Now we know that tan x is equals to sin x upon cos x. Okay, so let's derive the values. At x is equals to 0, tan x 0, pi by 2, 2 pi, 35, 3 pi by 2, and 2 pi. What are the values of tan for these angles, quadrantal angles? So tan 0 is 0, or you can calculate over here. Tan 0 is 0 upon 1, which is 0. Tan 90 is 1 upon 0, which is infinity. So this is infinity or not defined. Let's say infinity. Here you have 0 upon minus 1. Second value is sine, first value is cos. So 0 upon minus 1, which is 0. Here you have minus 1 to 0, infinity. So the value is shifting 0, infinity, then again 0, then again infinity. But during these values, there is a point over here, tan 45, which is 1, tan 135, which is minus 1. This is what you know. But based on quadrantal angle, this is what you're getting. You're dwindling between 0 and infinity. But यहाँ पर, when x is equals to pi, you have 0 upon minus 1. So instead of writing infinity, we'll write minus infinity. Sorry. 0 upon minus 1 over here at x is equals to 3 pi by 2. Instead of writing infinity, we'll write minus infinity. Here again, we'll get a 0. So let's see what we get. As x increases, the tan x increases from 0 to infinity first. Here you have 0, here you have infinity. It increases from 0 to infinity. Then it decreases, it further increases from minus infinity to 0, increases from 0 to infinity, and then increases from minus infinity to 0. In the first quadrant, tan x increases from 0 to infinity. Tan x increases from 0 to infinity. Let's draw the first quadrant first. Tan x is increasing from 0 to infinity. So this looks something like this in the first quadrant. What happens over here? Here you have minus infinity. Here you have 0, and here you have infinity. Here you have 0. So if you consider from this minus infinity to infinity, your value is increasing. Your value is increasing from minus infinity to infinity. Your value is increasing from minus infinity to infinity. Hold on, there's a shift over here. It increases from minus infinity to 0. Okay, this is not explainable with the help of this, right? This minus infinity part cannot be explained over here using simply this, right? Sorry about that. So for the time being, we'll consider by our understanding this value at tan 0, your value is 0.1 is 0. By our understanding, your tan value is 0.1, 1 upon 0, which is infinity. Here you have 0, and here you have infinity. Let's say it's infinity. So what happens over here? You're moving from 0 to infinity, and then you're moving from infinity to 0. you're moving from, in the first quadrant, you're moving from 0 to infinity, 0 to infinity. And then as you progress, you're moving from infinity to 0. So instead of going from infinity to 0, we are considering minus infinity to 0. Why are we considering minus infinity to 0? Because if you consider all the intermediate values, here your tan value is negative. Here your tan values is negative. If you would have considered plus infinity, then your tan values, this would have been your tan values, and here you have positive y-axis. Here y is tan x, and you cannot have positive value of tan. You should only have negative value of tan. So somehow, while shifting from pi by 2 to pi, you should have negative y-axis, y values. Hence, it is considered minus pi infinity to 0, even though it is not evident from your table, from your circle. That's why in the table, you have minus infinity to 0, because you need a negative tan. In the third quadrant, you need a positive tan. You need a positive tan, and your tan value is supposed to increase in the third quadrant from 0 to infinity. Again, from 0 to infinity. You're increasing, and the value of y is positive. So you're increasing, and the value of y is positive. What happens over here from 0 to minus pi by 2? Now 0 to minus pi by 2, as you say, if you consider from minus pi by 2 to 0, what happens from minus pi by 2 to 0? It is from infinity to 0, and your tan value is negative. So two things. First, infinity to 0, and tan value is negative as you're progressing from minus pi by 2 to 0. Tan value is negative and you're progressing to 0. So definitely the curve will look something like this. You're progressing to 0 while all the values are negative as you move from minus pi by 2 to 0. So your tan values will never be, will always be infinity at points of pi by 2, 3 pi by 2, minus pi by 2, and minus 3 pi by 2, etc. Or 2n plus 1 into pi by 2. Hence, x cannot have these values. This is what we also understood from your domain and range information. This curve will keep on continuing. It will continue to have this value. Sorry, it should be a little curve-like. And so forth. Here also you'll have the same curve-like structure. What happens with cot? Now cot x is again same. You need positive values in the first quadrant and in the third quadrant. So we'll try and mark up to over here. You need first quadrant 0 to pi by 2 and this quadrant. Your cot in these values, your cot is positive. Okay, first quadrant and third quadrant. In the rest of the quadrant, you need negative. So here you have positive values, and rest quadrants you have negative values. What happens from 0 to pi by 2? Again, let's write for cot now. Cot value is cos upon sine. So here you should have infinity. 0 upon 1 is 0. Minus 1 upon 0 is infinity. And here you have 0. What are you doing? As you're progressing from 0 to pi by 2, you're moving from infinity to 0. We do not know positive or negative infinity. So we are moving from infinity to 0. As you move from 0 to pi by 2, you need to move from infinity to 0. And you're progressing from 0 to pi by 2, and you are in the positive value. So it will look something like this. What happens further? Further, as you're moving from pi by 2 to pi, you're moving from 0 to infinity. That means you're decreasing in the negative value. You're decreasing in the negative region. Your y value should be negative. Decreasing in the negative region till you reach infinity. This pattern goes on in repeating itself. This kind of pattern you'll get. So if you observe tan and got, they are shifted mirror images of each other. But you need not remember this part. This is just an observation. What happens with sec and cosec? Now sec is the inverse of cos. Let's plot sec first. So sec is inverse of cos. We know that sec value, cos value and sec value, the range of sec, that means y value for sec, is very specific. It has to be from minus infinity to 1, sorry, minus 1, and then united with 1 to infinity. That means your y value will never hold any value between 1 to minus 1. We have considered these 2 points as 1 and minus 1. 1 and minus 1. Because the range for sec and cosec both are same. So this is sec and this is say cosec. Let's consider the other way around because I've drawn it in different fashion. So this is your cosec and this is your sec. We also understood that your trigonometric ratios should always have an angle attached to it, so you cannot just leave it at cosec. It is cosec x. Also, if you observe in the table, the x is not mentioned, so you can assume here you have the angle x. So like sine in itself does not hold any value. You have to attach an angle to it. So it is sine of that particular angle. Anyways, so for sec, your value should be positive in the first and the fourth quadrant. First and the fourth quadrant. So let's see where you have positive values. First quadrant 0 to pi, fourth quadrant 0 to minus pi to 0. Negative, second and third quadrant, positive again, negative, and then positive. Right. So here you have positive values and y cannot hold any value from 0 to 1. So y should hold value beyond 1. What else do we have? Sec is 1 upon cos. So cos is over here 1. Let's write the values for sec for these quadrantal angles. 1 upon 1 is 1. 1 upon 0 is infinity. 1 upon minus 1 is minus 1. And 1 upon 0 is infinity. So what is happening to the values? Observe the fourth quadrant and the first quadrant. We'll try and plot from fourth quadrant to the first quadrant. So fourth quadrant minus pi by 2, 2 plus pi by 2. Your value of angle is increasing from this point to this point. Your value of angle is increasing from minus pi by 2 to 0. Angle is as the angle increases, your sec x value is decreasing from infinity to 1. And beyond that point, it is increasing from 1 to infinity. So it takes a dip from infinity to infinity at 1. So first it is decreasing from infinity and it reaches the value of 1. Then it again increases and reaches the value of positive infinity. So first it is decreasing and then it increases. What happens over here? Over here, beyond this point, your x value increases further. So x is considered from pi by 2 to minus pi by 2, pi by 2 to 3 pi by 2, x is increasing. It decreases from infinity to minus 1. It increases from infinity to minus 1. How do we know that it increases? Because your sec value is negative. Over here. Here also your sec value is negative. So you're considering in the negative quadrant. This point onwards, it increases from, let's consider this as to be minus 1. From this point onwards, it looks something like this. Similarly, the curve repeats itself because the angles repeat itself, and here it's meeting one. Here also, this angle will repeat itself. Another reason for repetition is your trigonometric values will repeat itself because you are in the circle as x value increases. So for minus pi by 2 or 3 pi by 2, the values of trigonometric functions are same. What happens with Cos X? Cos X, you need a positive value wherever you have sign value positive, which is in the first and the second quadrant. So your Cos X value is positive in first and second quadrant and negative in the next two quadrants. Negative over here, positive over here. Cos X value, what happens to Cos X value? It is opposite of sine value. Let's find the quadrantal values for Cos X. One upon 0 is equals to infinity. Sorry. 1 upon 1 is 1. 1 upon 0 is infinity. Again, 1 upon minus 1 is minus 1. So from 0 to pi by 2, the value is shifting from infinity to 1. That means it is decreasing from infinity to 1. And further, it is increasing from 1 to infinity. So as you move from 0 to pi, the value is shifting first from infinity to 1, decreasing from infinity to 1, and then from 1 to infinity. Similarly, here the value will increase from infinity to minus 1 and then decrease from minus 1 to infinity. This curve will repeat itself. So these are the curves for all the trigonometric functions or trigonometric ratios. We'll study further in the next class. Thank you.